Welcome, listeners, to the latest episode of Astronomy Daily. I'm your host, Anna, here to bring you the freshest updates and thrilling discoveries from the vast universe above us. Whether you're tuning in from your daily commute, relaxing at home, or exploring the great outdoors, I'm excited to take you on this cosmic journey. We've got a lineup of fascinating stories today, from the perseverance of astronauts aboard the ISS to icy clues on Mars, mysterious dark comets in our solar system, and even a potential new discovery by the Hubble telescope. So sit back, relax, and let's dive into the wonders of the cosmos together. U.S. astronauts Butch Wilmore and SUNY Williams, currently stationed on the International Space Station, are expressing unwavering confidence in the Boeing Starliner spacecraft, despite some recent technical setbacks. This faith comes as they eagerly await their return, which NASA tentatively predicts for late July. It all started back on June 5th, when Wilmore and Williams blasted off aboard the brand new Boeing Starliner, a spacecraft that NASA is keen to certify for ferrying crews to and from the ISS. The journey to the station was initially expected to last about a week, but something unexpected happened. Thruster malfunctions and helium leaks detected during the mission led to delays, and their return has now been postponed indefinitely. Even though no official return date has been set, NASA officials remain hopeful for a late July timeline. Despite these challenges, both astronauts retain high levels of confidence. When asked during a live press call if they still had faith in the Starliner team and the spacecraft itself, Mission Commander Wilmore didn't hesitate. "We're absolutely confident," he declared. Williams echoed this sentiment, saying, "I have a real good feeling in my heart that the spacecraft will bring us home. No problem." As they continue their extended stay on the ISS, Wilmore and Williams have been making the most of their time. They've been involved in a variety of tasks, from changing out the pump on a machine that processes urine back into drinking water, to conducting scientific experiments like gene sequencing in the unique microgravity environment. They even tested Starliner as a safe haven vehicle in case of emergencies on the ISS, assessing how its life support systems perform with 4 people inside. But before Williams and Wilmore can come home, there's still some work to be done. Engineering teams need to run more simulations on the thrusters and helium seals to better understand the issues that arose. It's particularly important to investigate why the thrusters failed to engage initially during their approach to the ISS. There's a possibility that overheating due to excessive firing might be the reason, but the theories range from debris entering the propulsion system to potentially undersized seals installed by Boeing. NASA and Boeing have assured everyone that the critical systems expected to bring them home, the more powerful thrusters responsible for the deorbit burn, are unaffected. Despite the lingering uncertainties, they insist that Starliner could make the journey back safely if needed in an emergency. Interestingly, NASA official Steve Stitch mentioned that although there are no plans yet to bring the astronauts back using a SpaceX Crew Dragon, it hasn't been ruled out entirely. Such an outcome would be a significant blow to Boeing, especially given its recent challenges in the aerospace industry. Since 2014, both SpaceX and Boeing have been under contract with NASA to develop crewed spacecraft. While SpaceX successfully launched its crewed test in 2020 and has since flown numerous missions, Boeing's path has been fraught with more hurdles. Nonetheless, the prime option remains to bring both Butch and SUNY back using the Starliner. Let's keep our fingers crossed for Wilmore and Williams as they await their journey back to Earth, riding on the hope that the Starliner will bring them home safely and without further delays. Recent studies have provided intriguing insights into the climatic history of Mars, suggesting that the red planet may have experienced cold and icy conditions, quite similar to those found in subarctic regions on Earth. This discovery sheds new light on Mars's ancient environment and its potential to have supported life. Published in Communications Earth and Environment, the study drew comparisons between Martian soils from the Gale crater and those found in the subarctic climate of Newfoundland, Canada. The soils in Gale crater, which record Mars climate from 3 to 4 billion years ago, are key to understanding the planet's environmental history. During that period, water was more abundant on Mars, a time frame that coincides with the emergence of life here on Earth. Anthony Feldman, a soil scientist now at the Desert Research Institute, explains that while we might never find a direct analog to Martian soil on Earth, trends seen in terrestrial conditions can help answer long-standing questions about Mars. NASA's Curiosity rover, exploring Gale Crater since 2011, discovered significant amounts of X-ray amorphous material in the soil, which lacks the repeating atomic structure typical of minerals. This amorphous material, rich in iron and silica but lacking in aluminum, poses a challenge for scientists, as it's hard to characterize using standard techniques like X-ray diffraction. Feldman likens it to jello, a soup of different elements and chemicals sliding past each other. The presence of these materials, indicated by Curiosity's chemical analyses, is still not fully understood in the context of Mars's past environment. However, by examining analogous soils on Earth, Feldman and his team have made significant progress. They studied serpentine soils from various locations, including Newfoundland, the Klamath Mountains in Northern California, and Western Nevada. These areas exhibited similar chemical compositions, expected to be found in Gale Crater, enriched in iron and silica, but low in aluminum, and presented a range of environmental conditions. Through sophisticated analysis like X-ray diffraction and transmission electron microscopy, the researchers found that the soils in Newfoundland's cold, near-freezing subarctic conditions were chemically similar and lacked crystalline structure, unlike soils from the warmer climates of California and Nevada. This surprising result indicates that very cold conditions are crucial for the preservation of amorphous materials on Mars. Feldman emphasizes that water was essential for the formation of these materials, but near-freezing temperatures were required to preserve them. The study suggests that the abundance of X-ray amorphous material in Gale Crater aligns with conditions we might see in subarctic regions on Earth, like Iceland. This breakthrough improves our understanding of Mars's climatic history and hints at the complex interaction between water and temperature in its past environment. The persistence of these amorphous materials over geologic timescales implies a stability that further supports the cold and icy hypothesis. Ultimately, these findings deepen our comprehension of Mars's ability to potentially support life and underscore the importance of comparative planetary studies. By examining Earth analogs, scientists can extrapolate the conditions of distant worlds, pushing the boundaries of our knowledge and igniting curiosity about the mysteries of our solar system. Stay tuned for more developments in our quest to understand the red planet. Up to 60% of near-Earth objects could be dark comets, mysterious celestial bodies that might offer vital clues about one of the most profound questions in planetary science. How did water arrive on Earth? According to a recent study by researchers at the University of Michigan, dark comets are asteroids that likely contain or previously contained ice. This suggests that these enigmatic objects could have played a key role in delivering water to Earth. The notion that asteroids in the asteroid belt, the region between Mars and Jupiter, possess subsurface ice isn't new. This idea has been around since the 1980s, but this latest study lends more credence to it. According to Astor Taylor, a graduate student in astronomy and the lead author of the study, the findings provide compelling evidence that ice from the asteroid belt could be making its way into the near-Earth system. This supports the theory that icy bodies may have delivered water to Earth, a matter that remains a fervent topic of scientific debate. And dark comets are particularly intriguing because they straddle the characteristics of both asteroids and comets. Asteroids are rocky bodies that orbit relatively close to the Sun, within what's called the ice line, where any resident ice would have evaporated. Comets, on the other hand, typically carry significant amounts of ice and show a fuzzy coma, a cloud caused by sublimating ice and dust as they approach the Sun. Dark comets don't display this iconic coma, but they do exhibit non-gravitational accelerations, likely driven by the sublimation of subsurface ice. In their study, researchers analyzed 7 dark comets and estimated that as much as 60% of near-Earth objects could fall into this category. Their research indicates that these dark comets mostly originate from the asteroid belt, implying that the belt contains more ice than previously thought. This adds another potential pathway for transferring ice into the inner solar system, where it could ultimately end up on Earth. To trace the origins of these dark comets, Taylor and their team used dynamical models, assigning non-gravitational accelerations to different populations of objects. By running these models over 100,000 years, they found that the main asteroid belt, particularly its inner regions, is the most plausible source of these icy travelers. One of the most striking findings involved a dark comet named 2003 RM. This object follows an orbit close to Earth, then out to Jupiter and back again. The orbit is consistent with the trajectory of a Jupiter family comet, suggesting it might have originated from the outer parts of the asteroid belt. The study also found that the remaining dark comets came from the inner belt, formed by the breakup of an ice-rich progenitor body. As these icy bodies move towards the sun and cross the ice line, they begin to lose ice, accelerating and sometimes spinning so fast they break apart into smaller fragments. These smaller pieces continue to lose ice and spin even faster, eventually forming the small, rapidly rotating dark comets observed today. This compelling research not only broadens our understanding of near-Earth objects, but also enriches the broader discourse on how essential elements like water might have been transported to Earth. It opens new avenues for exploring the intricate mechanisms that shape our solar system and its habitable conditions. As we continue to study these dark comets, we inch closer to unwrapping the long-held mysteries surrounding the origins of water on our blue planet. Astronomers have been investigating the enigmatic Omega Centauri, the largest and brightest globular cluster visible from Earth, and there's groundbreaking news from this cluster once again. An international team, leveraging over 500 Hubble Space Telescope images gathered across 2 decades, has possibly pinpointed an intermediate mass black hole at its core. The smoking gun? 7 stars moving at incredible speeds, providing compelling evidence for this phenomenon. Intermediate mass black holes, or IMBHs, are a crucial part of the black hole evolutionary puzzle. Unlike their colossal supermassive counterparts found at galaxy centers or the smaller black holes formed from supernovae, IMBHs are elusive and much rarer. Their existence holds the key to understanding black hole formation and growth, especially the transition from stellar mass black holes to supermassive ones. Omega Centauri itself is a spectacular sight, visible to the naked eye from the southern hemisphere. Situated approximately 17,000 light-years away, it contains around 10 million stars, bound together by gravity, and is remarkable for its unusual properties. It rotates rapidly, has a remarkably flattened shape, and possesses a mass nearly 10 times greater than other large globular clusters, verging on the mass of a small galaxy. The dataset created by this team is the most extensive catalog of stellar motions ever produced for Omega Centauri. Upon analyzing these stellar motions, the researchers identified 7 stars whose velocity is so high that they should theoretically escape the cluster's gravitational pull entirely. The likely explanation for their rapid movements is an extremely massive object exerting a gravitational influence, and the most plausible candidate is an intermediate mass black hole with a mass at least 8,200 times that of our Sun. Previous studies had hinted at an IMBH in Omega Centauri, but were inconclusive. The alternate hypothesis suggested a dense cluster of smaller stellar mass black holes. However, the detection of stars exceeding the escape velocity crucially supports the black hole theory over the latter. If confirmed, this potential black hole would not only be significantly closer to us than the supermassive black hole at the core of our galaxy, but would also be one of the rare few intermediate mass black holes known to date. The team plans to delve deeper into this black hole's characteristics by studying the orbits of these high-velocity stars. For this, they're turning to the powerful instruments aboard the James Webb Space Telescope and other cutting-edge observatories. Additionally, Omega Centauri was spotlighted in a recent data release from the European Space Agency's Gaia mission, which examined over 500,000 stars within this cluster. The continued synergy between data from Hubble and Gaia missions underscores the unparalleled precision and sensitivity that modern astronomy achieves. This possible discovery is thrilling, opening a gateway to new understandings of how black holes evolve and what environments they thrive in. The investigation into Omega Centauri's core holds promise, not just for astronomers, but for anyone fascinated by the mysteries of the universe. So, as the hunt for intermediate mass black holes continues, Omega Centauri has certainly proven to be a galaxy-like cluster worth watching. Thank you for tuning in to today's episode of Astronomy Daily. If you enjoyed our cosmic journey, be sure to visit our website at astronomydaily.io for even more space news and to access all our past episodes. Don't forget to follow us on social media to stay updated with the latest discoveries and discussions. Just search for Astro Daily Pod on Facebook, X, and TikTok. Until next time, keep looking up and stay curious about the universe.